Hello everyone. Today let's talk about formal charge calculations of molecules and the ions. I'm Dr. Buddhika Liyanige. So let's go and find out formal charge calculation formula with examples. What is the formal charge? Formal charge is a concept used to determine the most plausible Lewis structure if there are multiple Lewis structures possible for a given molecule or the ion. We have a formula. Formal charge is equal valence electrons minus associated electrons. So if we take example carbon dioxide. Carbon dioxide is a linear molecule. There are two double bonded oxygen to the central carbon. Each oxygen two lone pairs. So if we consider formal charge on the right hand side oxygen, there are two lone pairs and four bonding electrons. So associated electrons are these bonding electrons plus lone pairs both. So we can rewrite the formula as formal charge is equal valence electrons minus lone pair electrons minus half times bonding electrons. If we take right hand side oxygen, valence electrons on oxygen is 6 because for main group elements valence electrons equal to their group number. So oxygen atom is located in group 6A. The number of valence electrons 6. So 6 minus lone pair electrons. You can see there are two lone pairs on oxygen. One pair means 2 electrons. Then total lone pair electrons 4. 6 minus 4 minus half times bonding electrons. Oxygen is double bonded. Double bond means 4 electron sharing. So half times 4. Then you can see 6 minus 4 is 2. 2 minus half times 4 is 2. 0 charge on the right hand side oxygen. The same way if you calculate on the left hand side oxygen and on the carbon, 0 formal charges. Therefore, the overall charge on the carbon dioxide molecule is 0. It is a neutral molecule. How to identify the dominant Lewis structure? A Lewis structure where the negative charges are located on the more electronegative atom is generally more dominant than one with the negative charge on the less electronegative atom. Let's take this example. In this structure, hydrogen, carbon and oxygen, there are three types of atoms. If you compare carbon and oxygen, carbon is less electronegative, oxygen is more electronegative. So more electronegative atom here has a positive charge and less electronegative atom has a negative charge. This is less favor or not favor because more electronegative oxygen should have negative character than carbon. For molecules, a Lewis structure with all formal charges equal to 0 is another way we can select the dominant Lewis structure. The Lewis structures with small formal charges 0, +1 or -1 overall is favor than the formal charges pluses or minuses 2, +, -3 or beyond the larger charges. So these are the guidelines we can select which structure is more dominant among the given structure for molecule or the ion. So let's go and find out with examples. Calculate the formal charge on each atom in the carbonate anion. Carbonate anion Lewis structure is carbon is a central atom. There are three oxygen connected to the carbon. The one is double bonded. The other two oxygen are single bonded. So I have given the names A oxygen, C oxygen, B oxygens. Let's calculate formal charge on each oxygen atom and carbon atoms. The formula to calculate formal charge is valence electrons minus lone pair electrons minus half times bonding electrons. First A oxygen. A oxygen valence electrons 6 because main group elements group number is equal to the valence electron count. Oxygen is in group 6A. Then 6 valence electrons minus lone pair electrons on the A oxygen is 6 electrons. 3 pairs 6 electrons minus half times bonding electrons. There is a single bond here. Single bond means 2 electrons. So if you solve this, you can see 6 minus 6, 0. 0 minus half times 2 is negative 1. So top oxygen or A oxygen is negative 1 charge. B oxygen 6 minus 4 minus half times, there is a double bond. Double bond means 4 electron sharing. So half times 4, then overall charge is 0 on B oxygen. The same way we can calculate C oxygen, 6 minus 6 minus half times 2, because it's a single bond to the right oxygen, charge is negative 1. Now charge on the central carbon. Carbon is located in group 4A, then group number 4, valence electrons 4. 4 minus 0. There are no lone pairs on carbon. Minus half times 8 bonding electrons. So one is a double bond or the two are single bonded to oxygen. The total is 8 electrons. So if you solve this, carbon charge is 0. Now you can see if you add all the individual charges together, minus 1 plus 0 plus minus 1 plus 0. The total charges indicated by outside charge on the ion, that is 2 minus. The second question is determine the formal charge on each atom in the nitrate and ion. NO3 charge is 1 minus. This is the Lewis structure of nitrate. NO3 charge is 1 minus. So let's label the oxygen A, B, C. The same formula, valence electrons minus lone pairs minus half times bonding electrons. First, let's calculate formal charge on A oxygen. 6 minus 6 half times single bond for 2 electrons. Charge on the A oxygen is negative 1. Second one, B oxygen. Same way, 6 minus half times 2, negative 1 charge on the B oxygen. C oxygen, 6 minus 4 because 2 lone pairs minus half times double bond means 4 electrons, charge is 0. Now charge on the nitrogen. Nitrogen is group 5 element, group 5A, then 5 valence electrons minus no lone pairs on nitrogen here. So 0 minus half times total bonding electrons 8. So charge is plus 1. Now you can clearly see if you add all the charges together, negative 1, positive 1 cancel, then the overall charge is negative 1. So that charge is indicated on the ion NO3, the net charge is negative 1. Let's talk about another example. Use formal charges to determine which skeletal arrangement for the CH2O molecule is the best choice. There are two different ways we can arrange the atoms in space. The first way, carbon and oxygen both are in the middle. The second way, carbon is a central atom, two hydrogen and oxygen attached to carbon. Let's find out formal charges on each atom and then determine which structure is valid. Valence electron count. If we count CH2O molecule valence electrons, carbon 4 valence electron times 1, 4, hydrogen 1 valency times 2, 2 electrons, oxygen 6 valency times 1, 6 electrons. So if you add, get the sum of these numbers, 12 electrons, 12 valence electrons on the structure. So with that electron count, let's complete the Lewis structure of these two skeletals. Now with labels A and B, let's calculate the formal charge on each atom. On the left hand side structure hydrogen A, formal charge is 0. 1 is valence electron minus 0 lone pairs minus half times 2. Single bond is 2 electron, then 0 charge on the hydrogen A. The same way for the carbon, plus 1 charge, oxygen plus 1 and B hydrogen is plus 1. On the second structure, hydrogen is 0, carbon is 0, oxygen is 0 and B hydrogen is 0. Now which structure is valid and what are the reasons? You can clearly see on the first structure, oxygen is electronegative element. It is plus 1 charge. But on the second structure, oxygen, zero charge. If we consider the electronegative element oxygen, zero charge is more favored than having +1 charge. Another reason is the first structure overall charge is there are 3 plus 1s, but the second structure overall charge is 0. All the atoms formal charges are 0. Therefore, due to these both reasons, the second structure is valid for CH2O. First structure is less favor for CH2O. I hope now you will understand how to calculate formal charge on any given type of molecule or the ion. Thank you all for watching.